Hi again. We are on video 2 for lesson 5-4, and we are going to be looking at example 1. I am not going to do example 1 on paper. We are going to follow it in the book, and then we are going to do the check it out on paper. I've already done it, and we will walk through it. This section of the video is really for helping you to see how all of this works together and to get a good review. I doubt you're going to have homework problems on this, but you may, and if you do, even a week down the road in the review sections, make sure that you come back to this. You'll have the foundation for it, and you'll have all of this material here to walk you through it. So we are looking at example 1. Again, we are on page 322. All right, in triangle GHJ, show that mid-segment KL is parallel to GJ. Let's look at that. That mid-segment KL is parallel to GJ. Also show that KL is 1/2 of GJ. That is a relationship that you are going to be learning in the next video in our theorem about this information. But KL, the mid-segment, is going to be 1/2 of the base of the triangle that is below it. So let's get started. The first thing we need to do is pretend like they do not already have the mid-segment there because they want us to find the information to put it there. The only way that we can do that is to find the midpoint of line segment HJ and line segment GH. So we need to use our midpoint formula, which, to remind you, is x plus x2 divided by 2 and y1 plus y2 divided by 2. Within parentheses, because this is an ordered pair, this is going to be an x and a y that tells you exactly where your midpoint goes on this line, and then you would have to do it using points H and J to find out where your midpoint goes on that line. Now remember, these formulas can be found, I think, way back in chapter 1. If not the slope, but the other two. If that's not true, you will find them in your table of contents to review them. Or you can copy what I've done and write them out to the side in your book. So we have found our midpoints using our midpoint theorem. We plugged in the coordinates that we needed to, and we found our x and we found our y. So that is all review from past lessons, and we'll practice it again in just a few minutes. The next thing, and then we did it for the other side, for HJ, and we have coordinates for it. Now we connect them, and there is the mid-segment that we're learning about. Okay, the next thing we need to do in order to show that this is parallel to this is we need to find something that y'all should be very familiar with, and that is slope. We're going to need to find the slope of GJ, and we are going to need to find the slope of KL. So let's come over here and look at our slope formula. You should be very familiar with this. If not, go back and review it. y2 minus y1 over x2 minus x1. So if we were trying to find the slope of GJ, we might say 2 minus -2 over 1 minus -7. And that would give us our slope. So once we have found the slope for this and this, we need to make sure that they are the same slope, because parallel lines have to have the same slope, as you well know. Okay, so we've accomplished that part of the problem, and now we are supposed to show that KL is 1/2 of GJ. KL is 1/2 of GJ. Remember, that's a relationship that we are now learning about, and we're about to learn a theorem about it. So the only way that we can compare those lengths is to find out what those lengths are. And on a graph like this, when the line is going at an angle, we cannot count boxes to find out how long the line is. So we have our nifty distance formula, and it says distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We simply use these coordinates, the g and the j, to do it the first time. So I'm going to bring this back over here where you can see, and I'm going to read these letters. So we might say 2 minus -2, which is really going to be 2 plus 2. That's going to be squared, plus 1 minus -7, or 1 plus 7, which is 8 squared. And then we add those two sums, and then if we can, we take the square root of it. The square root of that would actually come out to be 4.5, as they have done here. Then we must do the same thing with KL, and we find out whether that length is actually half of this length. So let's look at their answer. Is 2 radical 5 half of 4 radical 5? Yes. We cannot do anything with those radical 5s to simplify them. We can only compare the whole numbers here. This, if you will remember, this is a quick review. This is kind of like comparing 2x and 4x, because we can treat radicals kind of like we treat variables when we're adding and subtracting and multiplying and dividing and comparing numbers. So just like 2x would be half of 4x, 2 radical 5 is half of 4 radical 5, thus giving us the truth that KL is in fact half of JG. Okay, I'm actually going to do one more video before I introduce you to the theorem, because I want us to walk through a problem like this where you actually see me walking through the whole thing, just as a good review. So hang on tight for video number 3.